Welcome to my YouTube channel where we demonstrate and discuss everything related to theatrical and entertainment production crafts. Please subscribe to get the latest updates, posts, and demonstrations. While I will focus primarily on safety in the shops and comprehensive training and operating procedures for tools and machinery, I'll also demonstrate and discuss practical applications like flat and platform construction, scene painting, and more. If you'd like to see something specific, please let me know in the comments. Once again, please subscribe and power up the alert bell to get the most up-to-date notifications about new content. As a reminder, always seek out training from the shop supervisor or the technical director before attempting any task or demonstrations in this video. If you have never performed a task that I discuss or demonstrate, especially if it is one of the more advanced tasks or operations, you should only attempt them under the supervision of the shop supervisor or the technical director, especially if it is your first time doing so. If you haven't done something recently or would like a refresher, ask to be retrained, or have the shop supervisor or technical director supervise you performing the task. As always, be safe in the shops, on stage or backstage, or in the production support areas. This is our cold cut miter saw. It's one of the more accurate tools that we have for cutting metal. We have several options for cutting metal. We have the cold cut miter saw, we have an abrasive miter saw, we have a horizontal band saw, and then if you want to have a little bit less accurate cuts, if you don't need accurate cuts, we can do metal cutting with a Sawzall with a metal cutting blade, and we can use the portable band saw, the portable battery powered band saw. You can also do some cutting of metal with an angle grinder with a cutting wheel on it. Sometimes people do that for cuts that these bigger tools just won't be able to make. It operates by pumping a coolant onto the blade and cuts the metal with a special blade that the coolant then keeps cool. And the coolant also keeps the metal that you're cutting from overheating. Safety operating procedures are posted on the tool or next to the tool. These procedures represent the most important safety operations and considerations while using the tool or equipment, but are not intended to be comprehensive coverage of every possible use. For more complete safety instructions, please refer to the tool or equipment user manuals. Do not use this machine unless you have been instructed in its safe use and operations, and you are complying with college and department shop safety guidelines and procedures. Safety glasses are required and must be worn at all times while using this tool. All saws require safety glasses as minimum eye protection. Hearing protection is recommended. This tool does generate loud and high-pitched noise during operation. If you are using this tool repeatedly, you should wear ear protection. Long or loose hair, neckties, long sleeves, and loose or baggy clothing must be contained. Tie back or tie up your hair. Roll up your long sleeves. Tuck in your shirt or remove loose or baggy outer clothing altogether. Rings, watches, loose jewelry, or similar items that can become entangled in moving machinery should be removed before using this tool. Gloves should not be worn while operating this machine. Gloves can come into contact with rotating blades, increasing the chance of operator injury. This machine gets a lot of neglect, and we're going to start by cleaning it up because it's just a mess of shavings and garbage here. Metal shavings everywhere. There's metal shavings here. There's metal shavings there. All over through here. All these metal shavings were coated in coolant, and then the coolant dries on the machine and the metal rusts and the machine rusts, and it's just quickly reducing the life of the saw. All of this metal shavings should get cleaned up at the end of every day, and even several times throughout the day if you're doing a lot of metal cutting. It should never be left like this. And that includes getting the metal shavings out of these troughs where the water runs off and recirculates, but it needs to be kept cleaner than it is. So we're going to start by doing that. We can get a chip brush of some kind. These are really cheap disposable paint brushes. We usually use these at the drill press to keep the drill press table clean, and they are great for keeping this clean. Look at that, all these shavings just brush away. You can see where some of it is built up and left rust marks already. And I've only had this machine for a year. And this is what happens with neglectful use of it. We'll take some photos of these back sides where all this rust is building up. Really, really bad neglect. Get all these metal shavings off of here. And we can vacuum it out as well when we're all done. All this stuff has to go. All these metal shavings will also interfere with the ability for the machine to do its miter cuts and rotate to those miter positions. This one's a little different than the other machines, and I'll go over this again when I go through the features of it. It's got a lock lever here. Pull the lock lever, release it. This vise stays put. It's only the head of the saw that pivots. I think the saw needs some lubrication on this part so it can slide a little bit better. All the water and liquid and coolant has rusted it and made it not a happy thing. What we don't want to do is come out here with a wire brush and scrape off all the paint, make this rust worse. We could come up with a plastic scraper or something and try and scrape off some of the crusty bits, and then we're going to vacuum it out. I don't have a plastic scraper, so I'm going to gently use a metal scraper and scrape some of this rust buildup off. Where all that buildup has happened, and in here, scrape some of this out. That's where it likes to build up the most. And back here. We're going to get the shop vac and vacuum out as much of that metal residue as possible. There's some metal residue back here as well. It's not sucking up. All right, that's better. That's the way we want it. We always want to leave it that way. Clean all that off at the end of every single day, especially with this tool. You can't let it pile up. You can let sawdust pile up because it's not going to rust your tool, but all of this residue is going to rust and ruin and deteriorate the tool. Pre-operational safety checks. Locate and ensure you are familiar with all machine operations and controls. Controls and adjustments may vary from tool to tool, particularly among different manufacturers of the same type of tool. Controls for this machine. There's a trigger here and the handle that works in conjunction with the on switch over here. And you have to push the on switch in before the trigger will work. And you have to have control of your coolant here. This is the little faucet. If you're cutting ferrous metal, which is metal with iron in it, any kind of combination of iron or alloy of iron, you need to use coolant. The only time you wouldn't use coolant is if you have the right blade on the machine and you're cutting something like aluminum, a really soft metal. Coolant on, coolant off, and the coolant automatically flows when you pull this trigger. When you operate the tool, this comes down and lowers, the guard lifts up, the machine cuts into the metal, and then you lift it up. Coolant should be visibly flowing on the blade, coolant should be visibly rolling down the parts of the machine, collecting in this trough. and then going to the back here and draining back to the reservoir. There's a valve in the back here that can turn left and right, and that opens or closes the coolant flow. As we saw on the front is this handle. This locks it into place. Locking is over to the right and unlocking is over here. And then this can pivot to any degree of angle you want, up to about 45 degrees. It looks like it goes 45 degrees in both directions. It does not have a positive stop at 0, so bringing it back to 0 is going to require some trial and error and testing to make sure that you get it into the perfect 90 degrees if it's really essential that your cut is perfect. It does have a marking for 0, but there's no indent or positive stop for 0. We're going to bring it back. We're at 5 degrees. We're almost at 0 there. Pretty close to 0. Gonna lock it down. This tool does have a 3-phase connector on it, and we're going to need to plug it into 3-phase electricity. We've got 3-phase electricity throughout the room and the perimeter of the room. We've got a cable drop right behind me in the center of the room. There's electricity over there. There's electricity over there. There's electricity over there and there. All over the place. We got plenty of plugins. If you need an extension cord, there's a 3-phase extension cord here, and we can use that if we need to be out in the middle of the room. The Vise has 2 controls in it. This is a quick lock and release, quick lock and release, and then this dials us into whatever thickness of material we are cutting. So the way this works, let's say I'm cutting a lot of 1-inch square tubing, and I need to cut a lot of pieces. I'm going to be clamping the same material over and over again. That's where this lever comes in handy. Make sure this is in the down position. Tighten it down. When I want to take this piece out and put another piece of 1-inch square tubing in, all I have to do is release this. This comes out, put a new piece in, lock it down. I don't have to futz with the dial all the time. I'm doing a lot of repeated cuts. I pull this one out, I put the new one in, and I lock it down. It's going to come in handy for repeated cuts. Ensure the blade guard is present and properly functional. Adjust the guard if it hangs up or does not move freely. Do not operate if the guard is missing or faulty. Ensure that the saw head spring mechanism returns the saw to the full upright position. If it does not, report the fault to your teacher or to the shop supervisor and do not use the machine until it is repaired. Check your workspaces and walkways to ensure no slip or trip hazards are present. Keep the table and work area clear of all off-cut metal and metal residue. Clean the machine and table daily. Be conscious of coolant runoff wicking to the ends of the stock and creating slip hazards on the floor of the shop. Check the coolant level. Top off as needed. Fill the reservoir to the bottom of the chip strainer. Only use approved coolant mixed to the proper ratio. Confirm proper coolant flow. Open the manual flow valve behind the saw head. Turn on the coolant flow at the electronic controls. Always make sure the clutch adjustment wrench is removed. Do not over-tighten the clutch adjustment. The clutch is designed to allow the blade to stop when the feed rate is too fast or when the blade meets excessive resistance. Check the blade to make sure it is appropriate for the type of material you are cutting. Refer to the posted chart to determine which blade to use. Our saw typically has the blade designed for thin wall hollow profile stock. Operational safety checks. These are safety checks you must be aware of at all times while using the tool, and you must check them and perform them every time you use the tool on every single operation or cut. Keep your hands away from the cutting blade area. Always maintain a 6-inch finger no-go zone by keeping hands and fingers at least 6 inches away from the blade and the blade path. The workpiece must be held by the table vise and fence. Metal cutting tools must always use the provided table vise. Support long pieces on the ends with sawhorses or adjustable jacks. Always place the large side of the workpiece in the vise jaws to reduce the chance of a heavy off-cut piece binding on the blade. Allow the blade to come to maximum speed before proceeding with the cut. Use a single hand only to grip the feed handle while making the cut. The manufacturer recommends using only one hand to operate, presumably to reduce the chances that two-handed operation will overdrive the machine. Before clearing waste debris or making adjustments, switch off the tool, then wait for the machine to come to a complete stop. Immediately release the trigger if the saw blade should get stuck in a cut. Clutch adjustment may be necessary. Never over-tighten the clutch. The clutch is an essential safety device and should engage to prevent damage to the machine. If the clutch is engaging frequently, slow down your feed rate and/or replace the dull blade. Adjust the clamping vise to between 1/4 of an inch and 1/2 of an inch from the blade. Always use coolant when cutting ferrous metal. When cutting square, rectangular, or round tube, at least 3 teeth must be touching the work during cutting. Inspect the quality of the metal chips or shavings to confirm optimal saw speed and feed rate. Poor quality chips may also indicate that you are using the wrong blade or that your blade is dull. This part of the tool and the vise is essential. This piece of metal holds the waste material in place so it can't move and jiggle. So you don't want to remove that. It does have some adjustments. If you need to adjust it, it can adjust in and out. It's got 2 positions here. For now, I'm going to take this out so that you can see my cut a little bit more clearly in the video, just for the sake of the video. What's important for this blade is that you know that you have the right blade on the tool for the right task. The blade we have currently on the machine, and what we will have 90% of the time, is designed for cutting hollow profiles. So a hollow profile means a thin wall piece of tubing, square tubing like this. It's good for square tubing, round tubing, rectangular tubing, any of those kinds of tubing. And then if you're cutting solid stuff like angle iron or round stock or square stock is solid, you need to change it to a different blade so that you're using the right blade for the right task. We have a chart on the wall behind me over by the metal cutting station that says what to use for the cold cut saw blade selection. Look at that and get some help if you need to change it to cut into a different material. It is a miter saw, so like with all the other miter saws, radial arm saw, table saw, keep your fingers away from the no-go zone. Keep your hands at least 6 inches away from the blade. Your hands should never be near the blade because it should always be being held with the vise. You can't do a super fine cut on this. I can't shave off a fraction of an inch. If I'm bringing this down to line up to my mark, let's say I cut it 1/8 of an inch too long, I can't put it on 1/8 of an inch and try to cut off that little tiny shaving. I can't do that with most any metal cutting saw. If it's off, you're just gonna have to cut a different piece. I can't shave this off. I can take this to the grinder or to the metal sander and I can sand it down to get that 1/8 of an inch off, but I can't run it through any of the saws a second time. I can't just shave things off like I can with the wood saw. This blade is gonna deflect as it tries to cut through there, and the metal's going to push the blade away, and it's going to just make it a messy, awful cut. Always give yourself a little bit of leeway, so probably at least a couple of inches. It needs to be supported on this side as well as that side. That's a good rule of thumb. All of these cold saws have a clutch adjustment, and what the clutch does is it adjusts the tool so that at a certain amount of resistance, the blade will stop spinning so it doesn't overheat, so it doesn't lock up, so it doesn't destroy the motor. This one is pretty brand new. We don't have to do any fine tuning of the adjustments, but you should know that the clutch adjustment exists if it should need to be adjusted or if the tool is behaving oddly. If the blade should bind in any way, shape, or form, immediately release the trigger here and figure out what's going on. On the other side over here, we do have a gauge. This can be set to do stops and repeated cuts. Let's say I needed to make a lot of cuts that were a certain length. Now I could just go to there. Well, if it lined up. I think this can rotate. I don't really find that we end up using this, but you could use it to make repeated cuts. It's just almost always not necessary. We're not making a lot of tiny cuts. We're not a little machine shop here. I've usually just got it off to the side here, standing by in ready mode and just ignoring it. Let's demonstrate some common and basic cuts. Lock that in place. Power up. Green button on, green light on. Coolant from off to on. Obviously that's a stop button that turns it off. Turn it back on, and there's an emergency stop if you have an emergency, and to release that you have to twist it to the right. I gotta turn the green button back on again. You should be able to get this flowing, and you should see some coolant coming through. Just so we can see that on the video, you can see a lot of coolant coming off of that blade. That's a good coolant flow. You don't want to rush this. Come back up. That's it. That's the cold cut saw, and it's pretty awesome. Take this out. Let any of your liquid drain out, drain into here so it can go into the residue. Don't let these scraps pile up here. We have the metal recycling small trash can, so just toss the small cutoff scraps directly into the metal recycling. All of your tiny shavings and things we can collect and put in the hot trash. While this isn't technically hot trash because there's no sparks and fire being generated, it's just going to be easiest to collect the metal shavings and residue into this same bucket, whether it's hot or cold cutting. If I brush them off, if I collect them off the floor, you don't know which is hot metal and which is cold metal, so just put all your metal residue into the hot trash bucket. I've moved my piece over, I've locked it down, I'm gonna go for another cut. Just like that, quick release, drain my material out, throw my scraps away. It's a real nice, beautiful machine. The old one that we used to have, it was not as fun. It's an old Amber Brown Pedersoli machine, and it did a good job when the blade was sharp, but its coolant system was 20, 30 years old. It gets clogged up real easily. A lot of grease and grime and buildup. And this one's going to have grease and grime buildup too, especially if you neglect it. I've only made 3 cuts, and already I've got metal shaving residue building up here and all this liquid, and that's going to collect and solidify and start to rust my machine. So when I'm done, I need to clean that up. Let's try some rectangular tubing. This is also 1 inch wide by 2 inch wide, so I think I can just plop it in there as is and lock it in. Make sure it's resting firmly on both sides of there. While I'm here, I'm going to adjust this finally. I'll lay it flat in a second and test it in a different direction. As with all metal, on any of the tools, you are cutting on this top surface. That's the flat surface of one side or one face. That is the widest piece of metal. That's going to be the part where you need to slow down a little bit. Then once I'm cutting through these hollow sides, now I'm only cutting this thin piece of metal here and the thin piece of metal in the back. I can speed up a little bit, or I will speed up. The saw will go easier. And then when I get to the bottom level where it's flat again, it gets a little bit harder. So you need to adapt your cut to accommodate the fact that the saw has to work harder at these top and bottom positions as the saw blade comes into contact with the metal. Throw my scraps away. All I'm doing here is making scrap. I'm gonna lay this flat and try cutting on the flat side. I think that the vertical cut on the rectangular tubing is the easier one to do, but you may have a reason to cut this particular version. All right, here we go. Now I've got a longer cut here on this surface. Let's adjust this to a miter. We'll release this. I don't know what angle I've got, but we're just going to accept that. Looks like I'm 27 degrees thereabouts. This tool is going to be your cleanest miter cuts, especially if you're doing those 45-degree cuts. It's going to be your cleanest and most accurate 45-degree cuts. Really nice cuts. Really good cut. That would weld up really nicely. And now I've got a nice little parallelogram. Into the recycle bin. Just going to do one more cut. So this can be in two more smaller pieces so I can throw it away. I think the reason for not using two hands on this machine is to control the amount of force you're applying as it's cutting. With two hands, you're going to be compelled to apply with both arms and more force. And that's going to cause the blade to wear prematurely and the saw to overwork. So I think using it with one hand, even though it's a heavy machine, even though it's got all this motor that you're pulling down, that will help protect the longevity of the blade and will make your cuts better if you're just doing one hand and you're going a little slower.
Considerations when cutting long stock.
When you're cutting really long pieces of steel, it is important where you put your longest piece and where you put the smaller piece that's being cut off. Regardless of which side is the piece you want, you always want to have the longest piece clamped in the clamp and have the smaller piece be the cutoff piece. That's going to be kind of universal with all of the metal cutting saws. If you put the longer piece as the cutoff and you put the smaller piece in the clamp and you have the longer piece supported by some supports, if those supports are ever so slightly off as it's further away, what that's going to do is as the tool cuts through that, it's going to pinch the blade in the material, and on some of the tools, especially the horizontal bandsaw, it's going to bind. It may bind on this as well, but always put the long 20-foot piece of steel on this side and put the shorter 1 foot, 2 foot, 10 foot, whatever the smaller cutoff piece is on this side. You do want to support both sides if it's a long piece. You want them both supported, but you want the bigger piece on the left-hand side or whatever side the vise is in. Some tools, like the horizontal bandsaw, allow you to put the vise on the other side. So if you put it on the other side, then you need to have it on the right. This tool, I don't think is reversible that way. It's only got the vise over here. The vise does have some adjustability. I can slide this in and out via this set screw. Obviously, I don't want this going in so far that it's going to come into contact with my blade, but if I need more support, I can come all the way to there to my maximum 45-degree cut. I'm going to back it out just a little bit, just because I know if it's right on the line, somehow someone's going to find a way to cut into it. This can be closer to the cut, especially if you've got something delicate.
How to mix coolant to the proper ratio and other coolant tank care.
Let's talk about mixing up our coolant. This is very important. People don't mix it up to the right ratio. They just sort of fake it, and then we waste coolant, and it's way too concentrated. This is one brand of coolant, Speed Cool. I think we have a different brand now. Usually the mix ratio is 20:1. Now on the back side here, there's a scale, and we can calculate 20:1 if we do a little bit of math here. I know, math, theater, we have to do math. We have to do math in the shop all the time. If our scale here has 3 liters, that goes up to this part, that's got 3 liters. We want 20:1. 20% of 100 is 5. 20% of 1.00 is going to be 0.0. 5 hundredths of the liter. So if this is 3 liters, we're going to put in 15 hundredths of a liter. Now the thing is, this comes down here to its lowest measurement is 0.50. That's the smallest measurement possible on this. Half a liter is right there. So we can assume that halfway from that to the bottom is 0.25. So we want to go slightly less than 0.25 because we're targeting 0.15. We don't have a marking on here for 0.15, but it's just a little bit. This is the coolant I have. Cool Mist says 4 ounces per gallon, 4 fluid ounces. A gallon is 128 fluid ounces. We're going to see how this compares to our 20:1 ratio. 128 divided by 4 is 32. So this coolant ratio is recommending 1:32. So we're going to go a little bit stronger than that and just stick with 1:20, our coolant ratio here. So I'm going to there. That's actually a little bit more than I wanted. That's a little bit more than 1/4 of a liter. There we go. We filled it up. It's a nice light green color. It's not too dark, and that's great. We're going to store this in the back with the coolant tank so that it's ready to go when we need it. In the back is the access to the reservoir of coolant, and you need to make sure that's got enough coolant in it. If it doesn't have enough coolant, it won't pump up and flow properly. And the coolant should be at maximum at the bottom of this drain filter, and the drain filter needs to be cleaned out. It's really, really filthy. I'm going to go clean that out and shake that out. There also looks like there's a lot of residue that's gotten past this drain filter that's in the coolant tank, and the coolant tank needs to be drained and flushed and cleaned out. That's probably something that has to be done on an annual basis or a semi-annual basis, depending how frequently the tool is used. That looks better, much cleaner, and that will do a better job at filtering out the residue and the chips and shavings.
These are potential hazards to be aware of while operating this tool. Contact with metal waste or cut edges of metal stock could cause cuts or other injuries. When this tool is in operation, the blade is exposed, presenting a potential point of contact for injury. Always be aware of where the blade is and keep yourself and others away from the blade. Always wear safety glasses, safety goggles, or a face shield to protect your eyes and face from metal waste and moving coolant. Noise levels can rise above 100 decibels. Protect your ears by wearing hearing protection while using this tool. Do not use faulty equipment. If something is not working properly, or if you suspect something is wrong with the tool or machine, please report this to your instructor, the shop supervisor, or the technical director. Do not overload this machine by using a feed rate that is too fast or by exceeding the cutting capacity of the vise and blade. Excessive feed rate will reduce the quality of your cut, will prematurely dull the blade, and could damage the blade or the tool or injure the operator. On machines with speed selection options, choose the appropriate speed for the material being cut. High speed may not be appropriate for the chosen operation, particularly with thicker walled metal and solid material. Never overreach while operating this tool. If you are at full extension of your natural arm reach, don't risk losing your balance and losing control of the tool by overreaching. Stop the tool. Reposition yourself, the tool, and the workpiece so that you can continue with normal balance and arm reach. Do not allow the saw head to slam back into the upright position. Always be in complete control of the tool before, during, and after the cut. Wait for the saw blade to come to a complete stop after returning the saw head to its starting upright position. Never use acetone, brake cleaner, WD-40, or other solvents to clean metal parts. Solvents will also remove important lubrications on moving metal parts that are essential to smooth operation. Housekeeping. Turn off the machine and return all guards to their fully closed positions. Some miter saws can be stored in their locked down position when the workday is finished and during transportation. Always return any standard components on the machine. Someone keeps removing the hold down support and misplacing that part and its mounting bolts in order to make miter cuts. Consider turning your miter the other direction. In any case, put it back on after you're done making all of your cuts. Always restore your machine when you are done with it. Stay with the machine until the blade comes to a complete stop. Never walk away from a tool or machine until its blade and other moving components have fully stopped. Remove or restore any cutting stops or jigs. Leave the saw ready for use by the next person. Exercise the vise. Exercise the miter movement. Better yet, always leave the miter in an odd position so that the next user needs to return it to 0 for their 90-degree cuts. This will ensure that it is frequently moving through positions and less likely to lock up and freeze in place from neglect. Leave the machine in a safe, clean, and tidy state. This includes cleanup of scrap and debris on nearby counters and floors. Put away off-cut lumber or materials. Toss small scrap directly into the trash bins. Toss metal cutoffs into the metal recycling bin. Collect hot trash into the hot trash collection bucket. Sweep, clean, and dust off the counter, the machine, and the floor. Coolant runoff may have spilled onto the shop floor. Mop up any coolant puddles or overspray. Set up wet floor signs to prevent slips and falls. Collect metal cutoffs in the smaller trash bin labeled for metal waste and recycling. Clean metal debris and waste buildup on the tool body with a chip brush. Do this every day. Do this several times throughout the day if the tool is in high production use. Collect all metal waste into the hot metal trash collection bin. Turn the tool off, unplug it. And the most important thing, every day, every time you use it, clean all this crap off. Clean the residue off, brush it into the trough, vacuum it out, get it out of there, stop the rust from building up, and let's protect the longevity of the tool. While it's fresh, all these shavings are easy to move. Once they dry, that's when I have to start scraping, damaging the paint, and then paint damage encourages more rust, and that shortens the life of the saw. In order to clean, I have to move this head out of the way. There's no two ways about it. I've got to move that out of the way so I can get down in here and get those metal shavings out. This is the abrasive miter saw. It's your most common, inexpensive metal cutoff miter saw. It's also one of your least accurate ones. The saw cuts by use of this abrasive carborundum blade. It basically burns through the metal and burns it away at the same time as slowly burning down and shrinking the cutting disc in the same way that portable grinders have their discs quickly eroded away from use. If you're cutting pipe with this machine, it's going to be a lot of work. It's going to be slow. It's going to be sparks everywhere. It's going to be not the most accurate cuts. You're going to have a lot more to clean up on the pipe, and you're going to go through a lot of blades. The horizontal bandsaw is a much more accurate tool when making cuts than the abrasive saw. Cutting pipe on any tool is going to wear blades and go through blades a lot, whether it's the abrasive miter saw, the horizontal bandsaw, or the cold cut saw. By far the cheapest blades, of course, are the bandsaw blades or the horizontal bandsaw. If we're looking to have the most cost-effective and most accurate cuts for cutting pipe and cleanest cuts, this is the saw to use. The bandsaw blades can deflect, much like the abrasive saw, and the cold cut miter saw is least likely to deflect. And the horizontal bandsaw is a little finicky in operation. If you are impatient, you're going to keep knocking the blade off of the wheels and be frustrated with the tool all the time. The horizontal bandsaw is perhaps a little slower than the cold cut saw. But it's a lot less work for the operator because the weight of the saw head and machine is what's causing it to descend on the cut. The trick is adjusting the speed rate through the hydraulic system so that it goes at the right speed and doesn't go too fast and doesn't go too slow.
This particular piece of pipe you can see was cut with an abrasive saw. It's got this metal residue from being heated up and melted. Abrasive saws shoot out lots of sparks, and it sort of burns it away at the same time as reducing the size and diameter of the blade. A little bit of the blade wears away at the same time as it's burning through the metal. I would recommend using the horizontal bandsaw if you need a clean cut for pipe, or going to the abrasive saw. But the abrasive saw is just you're going to eat through blades. So I would recommend the horizontal bandsaw.
Choosing the correct blade for your cold cut miter saw can be a confusing task, especially when you look at the charts provided by the tool and blade manufacturers. On the right is the chart included in the user manual of Baileigh machines. On the left is a similar chart provided by Brobo, another manufacturer of metalworking tools. The chart on the left only determines tooth count. The Baileigh chart on the right also has tooth shape recommendations. Using the chart on the left, we'll see what blades are best for cutting common hollow profiles. Our saw has 315 millimeters or 12.5 inches diameter blades capacity, so we will use that column. For 1-inch square tubing, our outside diameter of 1 inch is equivalent to 25.4 millimeters. If our wall thickness is 16 gauge material, that comes to 1/16 of an inch or 1.52 millimeters. The chart suggests a tooth count between 240 and 320. If our wall thickness is 11 gauge, which is 1/8 of an inch or 3.04 millimeters, then we should be using 180 tooth blades. With 7 gauge wall thickness, we have 3/16 of an inch or 4.5 millimeters, so we would want to use a blade with 140 to 160 teeth, assuming this chart would extend to 4 millimeter and 5 millimeter wall thicknesses. Using the same 3 wall thicknesses with 2-inch square tubing, we shift down on the chart because 2 inches equals 50.8 millimeters. 16 gauge wall thicknesses would require 220 to 320 teeth on the blade. 11 gauge would require 180 teeth, and 7 gauge would require between 140 and 160 teeth. For 1x3 rectangular tube, let's treat it as a 3-inch outside diameter stock, so 3 inches equals 76.2 millimeters. 16 gauge wall thicknesses will require 240 to 300 teeth. 11 gauge wall thicknesses will recommend 200 teeth on the blade. And 7 gauge wall thicknesses will recommend 140 to 160 teeth on the blade. Though we could consider the smaller dimension of 1 inches as the correct outside diameter and use the recommendations from 1-inch square tubing. With 1.5 inch Schedule 40 galvanized or black pipe, remember that for pipe, the 1.5 inches is the inside diameter. We need to know the outside diameter when choosing a cold cut saw blade. Schedule 40 pipe with 1.5 inches inside diameter has an outside diameter of 1.90 inches. 1.90 inches equals 48.26 millimeters. The wall thickness of Schedule 40 pipe is 0.145 inches, which converts to 3.7 millimeters. This gives us a recommendation of a blade tooth count between 160 and 180 teeth. This size recommendation comes up among all of our examples, so 140 teeth to 160 teeth is a good place to start for a general purpose cold cut saw blade for our shop. Looking back at the Baileigh chart, it recommends 240 to 300 teeth for 1-inch square tubing. It recommends 220 to 300 teeth for 2-inch square tubing. And it recommends 240 teeth for 1.5 inch Schedule 40 pipe. Baileigh also suggests a tooth shape of BW for most of the thinner wall hollow profiles. BW tooth shape sets the teeth with alternating bevels, similar to ATB or alternating tooth bevel for woodworking blades. The C shape on the teeth is recommended for thicker walled stock and for most of the solid stock options. Both charts provide recommendations for solid stock based on stock diameter.
This machine gets a lot of neglect, and we're going to start by cleaning it up because it's just a mess of shavings and garbage here. There's just metal shavings everywhere. There's metal shavings here. There's metal shavings there. Just all over through here. All these metal shavings were coated in coolant, and then the coolant dries on the machine and the metal rusts and the machine rusts, and it's just quickly reducing the life of the saw. All of this metal shavings should get cleaned up at the end of every day, and even several times throughout the day if you're doing a lot of metal cutting. It should never be left like this. And that includes getting the metal shavings out of these troughs where the water runs off and recirculates, but it needs to be kept cleaner than it is. So we're gonna start by doing that. If I thought that was an awful condition to leave the machine, imagine how I reacted 3 months later when every stagecraft student using the machine chose to never clean it. This machine requires daily cleaning.
Don't do this with the cold cut saw. All of this metal residue is now coagulated and it's just destroying the saw. Clean this stuff up every day, people, come on. This is what a semester or part of a semester worth of student use has done to this machine. Ugh. Here's an initial cleaning, getting all that rust and gunk off. I've got to do more scrubbing, but I took a lot of WD-40 to it and scraped up as much as I could. But we're getting closer. Need to rinse it down and wash off the WD-40 residue and the rust residue and really clean out in all these troughs. But oh my God, it was just awful, wasn't it? It was awful. This is still pretty crappy, but it's better than it was. And all the parts move now, which is important. It was rusted shut so that it wouldn't pivot into miter positions, and the vise was rusted shut because of too much moisture. Gotta take better care of this thing.
And I thought a few metal shavings and light rust was bad. 2 or 3 months with absolutely no one cleaning the tool. Not once. All of the moisture and metal shavings need to be removed every day. I didn't get it on film, but the machine also had dozens of metal off-cut pieces scattered around in the shavings and in the trough. Never let your off-cut pieces build up around any of your tools. Have a trash collection bin nearby and put them directly into the bin as they come off of the cuts. If you let sawdust build up on the wood tools for a day or two, you aren't really creating any lasting damage to the tool. You're just being an a-hole and leaving a bigger mess for the sucker who has to clean up after you. But when you neglect any of the metalworking tools, especially this one with metal shavings and liquid coolant, you immediately degrade the tool and reduce its life expectancy as well as its ability to produce accurate cuts. Clean this tool every day. Clean up all metal shavings. Vacuum into the cracks and corners. Wipe the tool down to remove any coolant moisture residue. Exercise the vise. Exercise the miter movement. Better yet, always leave the miter in an odd position so that the next user needs to return it to 0 for their 90-degree cuts. This will ensure that it is frequently moving through positions and less likely to lock up and freeze in place from neglect. Clean the coolant filters and sieves. Check the coolant level and top off as needed. Replace the coolant and clean out the container when it begins to look sludgy. Always return any standard components on the machine. Someone keeps removing the hold down support and misplacing that part and its mounting bolts in order to make miter cuts. Consider turning your miter the other direction. In any case, put it back on after you're done making all of your cuts. Always restore your machine when you are done with it. The coolant tank is probably overdue for a major cleaning, so I'm going to clean it out. I'm also going to investigate to see if by chance people have been putting in plain water rather than water mixed with the appropriate coolant, and that's why we're getting so much rust. I'm looking in the tank already, and it's filled with a lot of rust and debris.
Here's what we look like in there, and I'm going to dump this out into a bucket and see if I can identify if there is actually any coolant in there. It looks like there's lots of rust and it really needs to be scrubbed out and cleaned out. Well, as I poured the water, it did not have any of the characteristic green color of coolant, and it looked pretty white, and that may be the cause of our rust. Someone may have been only putting straight water in. That's bad. Very bad. This is what our mixed coolant should look like. It should be this sort of green color. It shouldn't be any darker than that because then you've overused your coolant. And I'll talk about ratios in the training video. All right, we've done a major cleanup and getting most of that rust off. There's a lot of it really deep down into the cracks and crevices that I just can't get to. And fighting in here in the troughs. If I work much harder at this, I'm going to start scraping off the finish, the paint finish, and we don't want to do that. But the nice thing is the head moves freely, which is what it's supposed to do. It's supposed to always move freely. And the vise is now moving properly. The spring was jammed, it was skipping, and it's probably because we often do mostly 1-inch square tubing and not much bigger than that, so the vise doesn't get exercised in a great range. So we probably should, in maintenance, exercise it more and get some grease and lube there, lube the screw, and make sure that spring that's back there is not gummed up with gunk. And obviously keep these non-painted parts nice and greased up according to the manufacturer's specs. I think it's GL90. Recommended gear oil is the recommended surface treatment for those. Much happier. So I'm not going to turn it on today. I got to clean up and attach the splash guards still, but we've got the coolant refilled with coolant this time, not just plain water, and I'll fire it up tomorrow. Please remember to like, comment, and subscribe, and I'll see you next time with more technical theater content.